Here I'm going to introduce an introduction of thermodynamics. So first of all, what is thermodynamics? Thermodynamics is a term divided by the thermo means heat, dynamics means motion. So there's a different types of state systems are there and their process are there. So all this discussed in this presentation. Here in this presentation topic to be covered, first topic should be covered here, the scope of thermodynamics, where the thermodynamics should be used, and the system surrounding boundaries and types of thermodynamic systems are there, and adiabatic systems. So this topic will cover in coming slide. Now move to the next slide. So scope of thermodynamics. So the most of the important law of physical chemistry, including the want of law of lowering of vapor pressure, phase rule, and distribution law, can be derived from the law of thermodynamics. Means these law will be derived from thermodynamics. So it's still whether a particular physical or chemical changes can occur under a given set of conditions, temperature, pressure, and concentration. So it also helps in predicting how far the physical or chemical changes can proceed until the equilibrium conditions are established. So the overall process will predict by the physical or any changes, physical or chemical reaction. So until the equilibrium condition will attain. So now come to the next slide. Now come to the limitation of thermodynamics. So what is the limitation of thermodynamics? So limitation of thermodynamics is that the thermodynamics is applicable to macroscopic system. Means macroscopic system consisting of matter in bulk and not to the microscopic. Means only applicable for macroscopic, not microscopic system of individual atom or molecule. It ignores the internal structure of atom and molecule. So this will applicable only for the macroscopic system. So thermodynamics does not bother about the time factors. Means it's not depend upon time. So that is it does not tell anything regarding the rate of physical change or chemical reaction. It is the concerned only with the initial and final stage of the system. Suppose we take any example. So ice is converted into the water vapor. So only the state will consider for this process. Means solid state is converted to the liquid state, and the time factor is not considered in the system. That is the limitation of thermodynamics. So the limitation of thermodynamics is it's applicable only the macroscopic system. Means macroscopic, and it does not depend the time factor. It's only depend upon the state of initial and final state of the system. Now come to the next slide. So system, boundary, and surroundings. So first of all, you have to know what is the system, surrounding, and boundary. So a system is a part of universe which is under thermodynamic study, and the rest of the universe is surrounding. So a real and imaginary surface separating the system from the surrounding is called the boundary. For example, showing here this is a system is covered by a layer is called as a boundary, and after this boundary is called as surrounding. So system is separate, system and surrounding is separated by the boundary. So there is a surrounding is a open system, showing is a system and is covered by the wall, and another is the open system is showing. So system, boundary, and the surrounding. So there is a system, boundary, and surroundings are there. So in this slide, homogeneous and heterogeneous system. So first of all, what do you mean by homogeneous and heterogeneous system? When a system is uniform throughout is called as homogeneous system. For example, a pure single solid, a liquid or gases or mixture of gases are true solution of a solid in a liquid. So this system is considered as homogeneous system, means when a system is uniform throughout is called as considered as homogeneous system. A homogeneous system is made of one phase only. Uh, so a phase is defined as a homogeneous, means physically distinguished and mechanically separated portion of a system is considered as a phase. So a phase is you can say the phase is a physically distinguished portion that you should mechanically separate, that's considered as phase. For example, water has different phases there. For example, liquid phase and solid phase and vapor phase. So water is considered as three phases: solid, liquid and vapor phase. So a heterogeneous system is one which consists of two or more phases. In other words, it is not uniform throughout. It may be it may be changed. For example, ice is converted into water and ice is converted into vapor. Here the ice, water and vapor consist separate phases. So water is showing different types of phases are there. Phases are there. Here is a one component system but showing different phases. Here showing types of thermodynamic system. So there are three types of thermodynamic system depend on the nature of boundary. If the boundary is closed or sealed, no matter can pass through it. If the boundary is insulated, no energy, say heat, can pass through it. So there is an isolated system, open system and closed system. So three types of systems are there, means isolated systems are there, and closed system means neither heat nor matter is uh, exchange to boundary, and open system both energy heat and matter will exchange to the surrounding. So there are three types of systems are there: isolated, closed and open system. So now come to the next slide. First one is an isolated system. So uh, uh, when the boundary is both sealed and insulated, no interaction is possible with the surrounding. For example, is showing in the therefore an isolated system is a one that can neither matter nor energy to and form its surrounding. So here they're showing example of different systems are there. This is an open system, the showing the matter and heat all are exchanged here. But here they're showing the heat will change here. Heat will exchange to the surrounding. But here the insulated system, neither heat nor matter will exchange to its surroundings. So there is a showing example of open, closed and isolated systems are there. So in isolated system, neither heat nor matter will exchange to its surrounding. This is considered as insulated boundary. So closed system is that system where energy will exchange to its surrounding but matter will not exchange. So that system is considered as closed system, and the open system is that where energy and matter both are exchanged to its surroundings. So there is a three types of system, and the isolated system is that where the neither heat nor matter will exchange to its surrounding is considered as isolated system. Now come to the next slide. Another system is a closed system. So here the boundary is sealed but not insulated, means therefore A closed system is one which cannot transfer matter but can transfer heat in the form of heat and work and radiation to and from its surrounding. So in closed system only heat will exchange to its surrounding and matter will remain same. So a specific quantity of hot water contained in a sealed tube is example of closed system, while no water vapor can escape from this system. It can transfer heat through the wall of the tube to the surrounding. So a gas container in a cylinder filled with a piston constitute a closed system. As a piston is raised, the gas expand and transfer heat, means energy, in the form of work to its surroundings. So closed system is that system though where the only energy is transformed to its surrounding and matter will remain in same. So now move to the next slide. Is another showing the open system. An open system is a system that boundary is open and uninsulated. Therefore an open system is one which can transfer both energy and matter to and from its surroundings. So uh, energy and matter both will exchange to its surrounding. So example is a hot water container in a beaker placed on laboratory table is an open system where the water vapor, means matter, and also heat, means energy, is transformed to the surrounding through the imaginary boundaries are formed there. So zinc granules reacting with dilute hydrochloric acid to produce hydrogen gas in a beaker is another example of open system. Hydrogen gas escape and the heat of the reaction is transferred to the surroundings. So open system is that system where matter and heat both will exchange to its surroundings. The many example of this system is considered as the open system. Now move to the next slide. What are adiabatic systems? So first of all, what is adiabatic system? So those systems in which no thermal energy pass into or out the system are said to be adiabatic system, where means the any system where the no thermal exchange of energy will pass to exchange of the system, adiabatic system. So showing here the two types of properties are there: intensive and extensive properties. So these is a microscopic or bulk property of a system. For example, volume, pressure, mass, etc. can be divided into two classes, that is intensive properties and extensive properties. So now come to the next slide, showing here the intensive properties. So a property which does not depend on the quantity, you can uh, focus on the quantity of the matter present in the system, is known as intensive properties. Properties. So some example of intensive properties are pressure, temperature, density, and concentration. If the overall temperature of a glass of water, means our system, is 20 degrees centigrade, so then any drop of water in the glass has the temperature of 20 degrees centigrade, means so it does not depend upon the quantity of the system, where suppose the example of showing here the a glass of water whose temperature is 20 degrees centigrade. Suppose we pick one drop or one spoon of water, so all temperature will remain same, means 20 degrees centigrade. So this property is called as intensive properties, just like pressure, temperature, density, and concentration. So another example you can say that concentration. Suppose you have taken any concentration of any solution, the solution concentration will always same. Suppose we are taking 1 ml or 10 ml of that solution, so concentration is always same. So this property is considered as intensive properties. Similarly, another example is showing here the concentration of salt NaCl in a glass of water is 0.1 mole per liter. Then any drop of water of the glass also has a salt concentration of 0.1 mole per liter. So this is example of intensive properties. Another is extensive properties. So extensive property is that depend on the quantity of the matter present in the system is called as extensive property. For example, uh, extensive properties are volume, number of moles, enthalpy, entropy, Gibbs free energy, and some of these properties are unfamiliar to you, but these will be defined as illustrated later. By definition, the extensive properties are additive while intensive properties are not. So basic difference between the intensive properties and extensive properties is that extensive property depend on the quantity of the matter, and intensive properties does not depend the quantity of the matter. Suppose the concentration of any solution will remain same, suppose, and pressure is remain same, temperature is remain same. So that will example of intensive properties. And extensive properties is that depend on the quantity of the matter. So the volume means is an example of extensive properties. So let us consider as the example of glass of water. If we double the mass of water, the volume of is double, so it is to be number of mole and internal energy of the system will change. So this property is called as extensive properties. So the basic difference is intensive and extensive properties is that extensive property depend on the quantity of the matter, and intensive properties is depend does not depend the quantity of the matter. So this so the summary of this presentation is that system, boundary and surrounding, so isolated system, closed system, open system, intensive properties and extensive properties. So the system is that any system is differentiated by the boundary, means system, and surrounding is differentiated by the boundaries. So there are the different types of systems are there: isolated system and closed system, open system. So isolated system are that system where the matter and energy is neither exchanged to its surrounding, and closed system is that system where the energy is changed to its surrounding but matter will remain same. And open system, both energy and matter will always exchange to its surrounding. So these are the types of system: isolated, open and closed system. And the properties are that intensive properties and extensive properties. So intensive properties are that property which does not depend the quantity of the matter, but extensive properties are that properties that depend on the quantity of matter. The example of intensive properties are just like a temperature, concentration, and the extensive properties are volume, density, internal entropy are the extensive properties. For example, suppose we take the when we're taking the example of intensive properties, uh, the concentration of any of solution of any, suppose given point to any concentration are given, that suppose we take some amount of that concentration, so concentration will remain same when we change when we put say, any amount of that a particular solution. So this property is considered as intensive properties, and extensive properties are that properties which depend on the quantity of the matter. So these are the basic summary of this presentation. So thermodynamic properties are there, the systems are there. So now come to the next slide. These are the references and source textbooks are used for the presentation prepared for this presentation, and the material is presented in this lecture taken from the various books and internet sources, and this instructional material is for the instructional purpose only, and these are the example used for the preparation of this presentation. Now come to next slide. So thank you for watching this presentation. Thank you very much.